This is for Year 12 Specialists. It comes out of 15B. It's question number 3 and question number 6. And how do you set up these equations? How do I know when I have to add them together or how to multiply them together? So let's take number 3 and number 6 as an example. So number 3, scores on a mathematics component of a standardized test are normally distributed. Okay, so I know they're normally distributed with a mean of 63. So this is for the maths. So the expected value of maths is 63 and the standard deviation of maths is 10, which means the variance of maths is going to be 100. And the scores on English is also normally distributed, and the expected value of English is going to be 68 and the standard deviation of English is 7. Therefore, the variation of English will be 49. Assuming that the two components of the test are independent of each other, so they occur separately and they have no influence on each other. Find the probability the student's maths score is higher than their English score. So in this particular case, I want to find the difference between the two scores and make sure that if I do the difference is equal to the maths score minus the English score, I want to know the probability that maths is higher. So what is the probability that D is bigger than 0? Because if D is positive, it means maths is higher than English. So I've got D equals 1 times M plus -1 times E, which the expected value of D will be the expected value of M times 1 plus the expected value of E negative, so minus the expected value of E, which should be 63 minus 68. -5 is my expected value of the difference. And the variance of D is going to be 1 squared times 100 plus -1 squared times 49 equals 149. In the second example, suppose the weights of people are normally distributed with a mean of 82 and a standard deviation of 9. Expected weight is 82 and the standard deviation of weight is going to be 9. What's the maximum number of people who can get into an elevator? Okay, so they're all getting into the elevator at once. And they're all in the lift at the same time. Then the expected value of the total weight is going to be N times the weight of the average, which means the expected value of T will be N times the expected value of W. So it's going to be 82N. What is the maximum number of people who can get into an elevator which has, and the variation of T is going to be N squared times the variation of W. So it's going to be 9N squared is going to be the variation of T. Okay, so how do I work out these probabilities? Going back to question number 3, I want what is the probability that the maths score is higher than the English score. Therefore, what is the probability that D is bigger than 0? I know the mean of D is -5 and the variation D is 149. And on a calculator, if the lower is 0, the upper is infinity, sigma is the square root of 149 and the mean is -5. That gives me a probability of 0.34. So 34% chance that maths will be higher than English, so 0.3410 to 4 decimal places. And looking at the second example, I know this is normally distributed with a mean of 82N and a variance of 3N. I'm looking for what is the I want to be at least 99% sure that the elevator does not exceed 680, and that probability there needs to be 1%. So I'm going to use my z-score and give me the z-score where that value there is 1%. So I've got my inverse normal, right tail, probability 0.01, standard deviation and mu for the z value, and that gives me a z-score of 2.3263. So z equals x minus mean over standard deviation. So 2.2363 equals 680 minus 82n over 3n, solve for n. So I've got that on my calculator and I wish to go solve for x, which means I want to have what will be the least, so 7.6, and reading the question, what's the maximum number of people? Well, I need 7, because if I have 8, it's going to be bigger than that and the probability is going to be smaller.